Let me present to you the problem 5-23. Oakland National Bank has requested an analysis of checking account profitability by customer type. Customers are categorized according to the size of their account: low balances, medium balances, and high balances. The activities associated with the three different customer categories and their associated annual costs are given below. Opening and closing accounts for $200,000, issuing monthly statements for $300,000, processing transactions for $2,050,000, customer inquiries for $400,000, and providing ATM services for $1,120,000, with a total cost of $4,070,000. Additional data concerning the usage of the activities by the various customers are also provided. Account balance into low, medium, and high. Number of accounts opened or closed: 15,000 for low, 3,000 for medium, 2,000 for high. Number of statements issued: 450,000 for low, 100,000 for medium, 50,000 for high. Processing transactions: 18 million for low, 2 million for medium, 500,000 for high. Number of telephone minutes: 1 million for low, 600,000 for medium, and 400,000 for high. Number of ATM transactions: 1,350,000 for low, 200,000 for medium, 50,000 for high. And lastly, number of checking accounts: 38,000 for low, 8,000 for medium, and 4,000 for high. I will be presenting first the solution for requirement 1 and requirement 2, which are: first, calculate the cost per account per year by dividing the total cost of processing and maintaining checking accounts by the total number of accounts. What is the average fee per month that the bank should charge to cover the cost incurred because of checking accounts? Second, calculate the cost per account by customer category using the activity rates. For the first requirement, we are asked to calculate first the cost per account per year by dividing the total cost of processing and maintaining checking accounts of $4,070,000 by the number of accounts from low, 38,000, from medium, 8,000, and high, 4,000, or a total of 50,000. To get the average fee per month, we divide the cost per account per year by the number of months in a year, or 12 months, and we get 6.78. For the second requirement, we will first calculate the unit rate of each activity by dividing each activity's annual cost by its total account balance from low, medium, and high. Now that we have the unit rate for each activity, we will assign cost by multiplying these rates by the account balance of each customer category for each activity so we can get the total cost. Here, we divide our total cost by each category's number of checking accounts and we get the cost per account of each customer category. Let us now proceed for the third and last requirement. For the third requirement, currently, the bank offers free checking to all its customers. The interest revenue averaged $90 per account. However, the interest revenues earned per account by category are $80, $100, and $165 for the low, medium, and high balance accounts respectively. Calculate the average profit per account or average revenue less average cost from requirement 1. Now calculate the profit per account using the revenue per customer type and the unit cost per customer type calculated in requirement 2. For the last requirement, after the analysis in requirement 3, a vice president recommended eliminating the free checking feature for low balance customers. The bank president expressed reluctance to do so, arguing that the low balance customers more than made up for the loss through cross sales. He presented a survey that showed that 50% of the customers would switch banks if a checking fee were imposed. Explain how you could verify the president's argument using the activity-based costing. As for the third requirement, we will compute first for the average profit per account through getting the difference between the given interest revenue per account of 90 and the cost per account per year computed in the first requirement. And we will get 8.60 average profit per account. Next, we will compute the profit per account by customer category. This is done through getting the difference between the given interest revenues earned per customer category and cost per account of each category as computed in the second requirement. For the last requirement, to verify the president's argument, we will have to calculate the profits from all the balance categories using activity-based costing. Then we will compare the loss from low balance checking accounts from the profits from the 50% of the cross sales. If the latter is higher than the former, then the president is right.
John Thomas, Vice President of Mallet Company, has been supervising the implementation of an activity-based cost management system. One of John's objectives is to improve process efficiency by improving the activities that define the processes. To illustrate the potential of the new system to the President, John has decided to focus on two processes: production and customer service. Within each process, one activity will be selected for improvement, materials usage for production, and sustaining engineering for customer service. Value-added standards are identified for each activity. For materials usage, the value-added standard calls for 6 pounds per unit of output. The value-added standard is based on the elimination of all waste due to defective molds. The standard price of materials is $5 per pound. For sustaining engineering, the standard is 58% of current practical activity capacity. This standard is based on the fact that about 42% of the complaints have to do with the design features that could have been avoided or anticipated by the company. Current practical capacity is defined by the following requirements: 6,000 engineering hours for each product group that has been on the market or in development for 5 years or less, 2,400 hours per product group of more than 5 years, 4 product groups have less than 5 years experience, and 10 product groups have more. There are 24 engineers, each paid a salary of $60,000. Each engineer can provide 2,000 hours of service per year. No other significant costs are incurred for the engineering activity. Actual materials usage for 2008 was 25% above the level called for by the value-added standard. Engineering usage was 46,000 hours. A total of 80,000 units of output was produced. John and the operational managers have selected some improvement measures that promise to reduce non-value-added activity usage by 40% in 2006. Selected actual results achieved for 2009 are as follows: 80,000 units produced, 584,800 pounds of materials used, and 35,400 engineering hours. The actual prices paid for materials and engineering hours are identical to the standard or budgeted prices. We are required to calculate the non-value added usage and costs for materials usage and sustaining engineering for the year 2008. We also have to calculate the cost of unused capacity for engineering activity. Using targeted reduction, we are to establish Kaizen standards for materials and engineering. Using the Kaizen standards, we are to compute the 2009 usage variances expressed in both physical and financial measures for materials and engineering. We are to comment on the company's ability to achieve its targeted reductions. In particular, we are to discuss the measures that the company must take to capture and realize reductions in resource usage. Based on the problem earlier, the standard quantity for materials usage is 6 pounds per unit. The standard price is $5 per pound. For sustaining engineering, we are given standard quantity of 58% of practical capacity. To calculate for the practical capacity, we must add all engineering hours of all product groups. For product groups with 5 years or less experience, the engineering hours is 6,000. For product groups with greater than 5 years experience, the engineering hours is 2,400. There are 4 product groups with 5 years or less experience. There are 10 product groups with greater than 5 years experience. To get the total engineering hours, we must multiply the number of product groups to the engineering hours per product group. The engineering hours for product groups with 5 years or less experience is 24,000. The same with the engineering hours for product groups with greater than 5 years experience. To get the total engineering hours, we must add the two figures. This gives us a practical capacity of 48,000. To get the standard quantity for sustaining engineering, we are to multiply 58% to the practical capacity, which is 58% multiplied to 48,000, which gives us a standard quantity for sustaining engineering of 27,840. For the standard price, we are given the number of engineers and their salaries. There are 24 engineers with salaries of 60,000. We can get the total salary by multiplying the two figures, which gives us 1,440,000. By dividing the total salary by the total engineering hours, we will get the standard price for sustaining engineering. That is 1,440,000 divided by 48,000, which gives us a standard price of $30 per hour. The actual materials usage for 2008 is 125% of the standard. So the standard for the actual materials usage is 6 pounds per unit. To get the actual materials usage for 2008, we have to multiply 125% to the materials usage per unit of $6 multiplied to the units produced, which gives us actual materials usage of 600,000 pounds for the year 2008. The rest of the given data are engineering hours of 46,000, units produced of 80,000. For 2009, materials usage of 584,800, engineering hours of 35,400, and total number of units produced of 80,000. As mentioned in the problem, the target reduction as a result of the implementation of the Kaizen standard is 40%. We are required to calculate for the non-value added cost of materials and the non-value added cost and unused capacity variance for engineering hours. To calculate for the non-value added cost of materials, we are going to compare the actual materials used to the value added standard. The actual materials used for 2008 is equal to 600,000. The value added standard for materials is equal to 6 pounds of materials per number of units, which is 80,000, giving us value added standard of 480,000. To calculate for the excess materials used, we're going to deduct 480,000, which is the value added standard, from the actual materials used, giving us excess materials used of 120,000. To calculate for the non-value added cost of materials, we're going to multiply the excess materials used to its price. The price of the materials is given at $5 per pound. To calculate for the non-value added cost of materials, we're going to multiply 120,000 by the price of $5 per pound, giving us a non-value added cost of materials of $600,000. To calculate for the non-value added cost of engineering hours, we're going to compare the actual cost of engineering hours to the value added standard. So the practical capacity for the engineering hours is equal to 48,000. The value added standard, as computed earlier, is 27,840. The excess engineering hours for sustaining engineering is equal to 20,160. To calculate for the non-value added cost of engineering hours, we're going to multiply the excess engineering hours to its price. As computed earlier, the price of the engineering hours is $30 per hour. We're going to multiply that with the excess engineering hours. And we will get the non-value added cost of engineering hours of 604,800. The next requirement is to calculate for the unused capacity variance for engineering hours. The practical capacity for engineering is equal to 48,000 hours. To calculate for the unused capacity, we're going to deduct from it the actual usage. Given actual usage is equal to 46,000 hours. The unused capacity is 48,000 minus the 46,000 actual usage, which is 2,000 hours. The price for the engineering hours is computed earlier as $30 per hour. By multiplying the unused capacity to its price, we're going to have the unused capacity variance of $60,000. Our next requirement is to calculate for the Kaizen standard for the activity levels for the year 2009. To do so, we must first find the Kaizen standard for non-value added activity levels. In computing the Kaizen standard for non-value activity level, we must first deduct the target reduction from the current level of non-value added activity. The non-value added activity level for materials in the year 2008 is equal to 120,000. For sustaining engineering, it is 20,160. To calculate the reduction, we're going to multiply the figures above to the rate of 40%. So 120,000 multiplied to 40%, which is the target reduction. For sustaining engineering, it is the non-value added activity level, 20,160, multiplied to the target reduction of 40%. To calculate for the Kaizen standard for non-value added activity level, we're going to deduct the reduction from the current level of non-value added activity. For materials, it is 120,000 minus 48,000, giving us a Kaizen standard of 72,000. For sustaining engineering, it is 20,160 less 8,064 of reduction, giving us a Kaizen standard of 12,096. To calculate for the Kaizen standard for activity levels, we're going to add the value added activity level to the Kaizen standard for non-value added activity level. The value added activity level for materials is as computed earlier, 480,000. For sustaining engineering, the value added activity level is 27,840. To get the Kaizen standard, we're going to add the Kaizen standard for the non-value added activity and the value added activity. So for materials is 72,000 plus 480,000, and for sustaining engineering is 12,096 plus the value added activity level. It is 12,096 plus the value added activity level 27,840, giving us a Kaizen standard of 39,936. So the final answer for the Kaizen standards for activity levels, for materials it is 552,000 pounds, and for sustaining engineering it is 39,936 engineering hours. Our next requirement is to compute for the materials usage variance and the labor efficiency variance. And for the sake of the analysis which we are going to do later, we're going to compute the unused capacity variance for sustaining engineering. To calculate for the materials usage variance, we're going to get the actual materials used for the year 2009, which is 584,800. We're going to deduct from that the Kaizen standard for the materials used. The Kaizen standard is equal to 552,000 pounds. By deducting the Kaizen standard from the actual materials used, we're going to get the excess materials used of 32,800. By multiplying the excess materials used of 32,800 to the standard price of $5 per pound, we're going to get a materials usage variance of $164,000. The materials usage variance is a unfavorable variance. To calculate for the labor efficiency variance, we're going to get the actual engineering hours used, which is 35,400, and the Kaizen standard for the engineering hours is equal to 39,936. By deducting the Kaizen standard of 39,936 from the actual engineering hours of 35,400, we're going to get a negative labor efficiency variance of 4,536. by multiplying the said labor efficiency variance in hours to the hourly rate of $30, we're going to get the labor efficiency variance in dollars. The labor efficiency variance in dollars is equal to a favorable variance of 136,080. Now we are going to calculate for the unused capacity for the sustaining engineering. The practical capacity for the sustaining engineering is equal to 48,000. For 2009, the actual usage is equal to 35,400. By deducting the actual usage from the practical capacity of 35,400, we're going to get the unused capacity of 12,600. Based on the computation, the company is successful in improving their labor efficiency. However, they fell short in minimizing the waste of materials. To tackle the issue of cost reduction for both materials and sustaining engineering, managers must address the respective root causes. For the waste of materials, its root causes are the defective molds. Managers must order the replacement of defective molds with new ones. This may cause the company to incur some costs, but in the long run, the cost of the said decision would be offset by the cost reductions in the years to come. To save labor costs, the company must reassign 6 engineers from sustaining engineering to other activities. This would give them cost savings of $360,000 by cutting the practical capacity by 12,000 hours.
Okay, so for today, we're going to answer case 5-67, which is about activity-based costing, budgeted operating margin. So let me read the problem to you. Whitestone Company produces two sub-assemblies, JR14 and RM13, used in manufacturing trucks. The company is currently using an absorption costing system that applies overhead based on direct labor hours. The budget for the current year ending December 31, 20x1 is as follows. For JR14, the sales in units is 5,000. Sales revenue is $1,700,000. Its cost of goods manufactured and sold are computed as follows. Beginning finished goods inventory is $240,000. Its direct material, direct labor, and applied manufacturing overhead are as follows: 1,185,185 and 544.25. And its cost of goods available for sale is 1,969,210. Its ending finished goods inventory is 240,000 and its cost of goods sold is 1,729,210 and its gross margin is negative 29,210. The applied manufacturing overhead corresponds to the total manufacturing overhead applied on the basis of direct labor hours. As for RM13, its sales in units are 5,000. Its sales revenue is 2,200,000. Its beginning finished goods inventory is 300,000. Direct material, direct labor, and applied manufacturing overhead are as follows: 1,750,000, 92,593, 272,013, and its cost of goods available for sale is 2,414,606. Its ending finished goods inventory is 300,000. Its cost of goods sold is 2,114,606, and of course its gross margin is 85,310. 394. And again, its applied manufacturing overhead pertains to the total manufacturing overhead applied on the basis of direct labor hours. And the total cost pools are as follows. Machining, it is 424,528. Assembly, 216,981. Material handling, it is 56,604. Inspection, it is 117,925 with a total of overhead of 816,038. Mark Ward, Whitestone's president, has been reading about a product costing method called activity-based costing. Ward is convinced that activity-based costing will cast a new light on the future profits. As a result, Brian Walters, Whitestone's director of cost management, has accumulated pool of information for this year shown on the following chart. This information is based on a product mix of 5,000 units of JR14 and 5,000 units of RM13. So the cost pool information for 20X1 are as follows. So the cost pools are direct material, machining, assembly, material handling, and inspection. And the activity are as or the activity driver are as follows. For direct labor, it is the direct labor hours. For machining, it's machine hours. For assembly, it is assembly hours. For material handling, it is the number of parts. And lastly, inspection, which is for inspection hours. So for JR14, the direct labor hours is 10,000. Its machine hours is 15,000. Its assembly hours is 6,000. Number of parts is 5. Inspection hours is 5,000. For RM13, the direct labor hours is 5,000. Machine hours is 30,000. Assembly hours is 5,500. Number of parts is 10. And inspection hours is 7,500. In addition to the following information is projected for the next calendar year 20X2. The beginning inventory finished goods in units for JR14 and RM13 are as follows: 800 and 600. Ending inventory finished goods in units, 700 for JR14 and 700 as well for RM13. And sales in units for JR14 is 5,100 and 4,900 for RM13. On January 1, 20X2, Whitestone is planning to increase the prices of JR14 to $355 and RM13 to $455. Material costs are not expected to increase in 20X2, but direct labor will increase by 8% and all manufacturing overhead costs will increase by 6%. Due to, due to the nature of the manufacturing process, the company does not have any beginning or ending work in process inventories. Whitestone uses a just-in-time inventory system and has materials delivered to the production facility directly from the vendors. The raw material inventory at both the beginning and the end of the month is immaterial and can be ignored for the purposes of a budgeted income statement. The company uses the first in, first out or FIFO inventory method. So we are required to answer the following questions. For number 1, Explain how activity-based costing differs from the traditional product costing methods. Number 2, using activity-based costing, calculate the total cost for the following activity pools: machining, assembly, material handling, and inspection. Round to the nearest dollar. Then calculate the pool rate per unit of the appropriate cost driver for each of the 4 activities. Refer to Exhibit 6 regarding the calculation of the pool rate. Number 3, prepare a table showing for each product line the estimated 20x2 cost for each of the following cost elements: direct material, direct labor, machining, assembly, material handling, and inspection. Round to the nearest dollar. Number 4, prepare a budgeted income statement showing the gross margin for Whitestone Company for 20x2 using activity-based costing. The statement should show each product and a total for the company. Be sure to include detailed calculation for the cost of goods manufactured and sold. Round each amount in the statement to the nearest dollar. So let's try to solve this one in Excel. So for number 1, there I have already laid out all of the informations needed. So I'm just going to show you how to calculate for the numbers. So again, for question number 1, explain how activity-based costing differs from the traditional product costing methods. So, activity-based costing differs from the traditional product costing methods in such way that the number of indirect pools are expanded, which can be allocated to specific product, thus making product costing more accurate than the traditional product costing method. Traditional product costing, on the other hand, takes only one pool of the firm's total overhead costs to allocate universally to all of its products. Now, let's proceed on to the second requirement. So, using the activity-based costing, calculate the total cost for the following activity pools: machining, assembly, material handling, and inspection. Round to the nearest dollar, then calculate the pool rate per unit for the appropriate cost driver for each activities. Hint: refer to Exhibit 5-6 regarding the calculation of the pool rate. So if we're going to look at the Exhibit 5-6, it looks like this. We have a column for the activity, have a column for the cost pool, we have a column for the cost driver, and then we have the cost driver quantity, and then that's how we're going to calculate for the pool rate. So basically, we're just going to divide the activity cost pool by the cost driver quantity for each activity, and then we're going to get the pool rate. So if we're going to apply that to our problem, so I've already made a table with regards to that. So first, let's calculate the total activity costs pool. So since what we have right here is the cost pool for 20x1, so here in number 2, we are going to calculate the activity cost pool for 20x2. So how do we do that? Since based on the problem, let me just go back to the problem. It is stated that, oops, where is it? Okay. It is stated in the problem that all of the manufacturing overhead cost will increase by 6%. So In the problem, we're just going to increase the activity the values of the activity pools by 6%. So for machining, that is 424,528 multiplied by 1.06. For assembly, that is 216,981 multiplied by 1.06. For materials handling, that is 56,604 multiplied by 1.06. For inspection, that is 117,925 multiplied by 1.06. So if we're going to get the rounded amount, oops, for machining, that would be 450,000. For assembly, that is 230,000. For materials handling, that is 60,000. And for the inspection, that is 125,000. So our total activity cost pool will be 865,000, or this corresponds to the total manufacturing overhead. So the cost driver for machining is the direct labor hours. For assembly, that is machining hours. For materials handling, okay, Joe, let me repeat that. Oh, I'm so sorry. For machining, that is machine hours. For assembly, that is assembly hours. For materials handling, that is number of parts per unit. And inspection, that is of course inspection hours. So now let's get the cost driver quantity. So for machining, that is 15,000 from JR14 and 30,000 of or for RM13. So we're going to have a total of 45,000 machining hours. For assembly, that is 6,000 of or 6,000 for JR14 and 5,500 for RM13, which would give us a total of 11,500 assembly hours. Okay, so for the number of parts, that is for JR14, the number of parts per unit is 5,000. Then we're just going to multiply it by the sales in units in 20x1, which is 5,000, and then we're just going to add it to the number of sales in units, which is 5,000 multiplied by the number of parts per unit for RM13, and that would give us a total of 75,000. Now for inspection hours, that is 5,000 for JR14 plus 7,500 for RM13, and that would give us 12,500. So if you want to be a little if you want your table to be detailed, so let's allocate this total cost driver quantity to the two sub assemblies for JR14, that is 10, 15,000. Oops. Wait, wrong numbers. 15, 6, 5 times 5,000 for RM13, 30,000, 5,500, then multiplied by 5,000 and 7,500. Now we'll be able to compute for the pull rate for each activity. So for machining, that would be 450,000 divided by cost driver of 45,000, and that would give us the pull rate of 10. For assembly, that is 230,000 divided by 11,500, and that would give us 20. For machine materials handling, that is 60,000 divided by 75,000, that would give us 0.8. And for inspection, that is 125,000 divided by 12,500, and that is 10. So that's how you compute for requirement number 2. So now let's compute for requirement number 3. Prepare a table showing for each product line the estimated 20x2 cost for each of the following elements: direct material, direct labor, machining, assembly, material handling, and inspection. Round to the nearest dollar. Okay. So first, let us get the budgeted uh, amounts in 20x1. For direct material, that is 1 million for JR14 and 1,750,000 for RM13. For direct labor, that is 185,185 for JR14 plus 92,593 for RM13. And that would give us 277,778 for machining. That is a total of 424,528 for assembly. That is 216,981 for materials handling. That is 56,604, and for inspection, that is 117,925. So according to the problem, or if we're going back to the problem, it is said that on January 1, 20x2, material costs are not expected to increase. Material costs are not expected to increase. But direct labor will increase by 8%. And of course, all of the manufacturing overhead costs will increase by 6%. So if we're going to apply that to the current problem, so the percentage of increase for direct materials is 0. For direct labor, that is 8%. And for all of the manufacturing overhead, that is 6%. So the estimated amounts for 20x2 for direct materials is still 2,750,000 because there's no percentage of increase for 20x2. For direct labor, that is 277,778 multiplied by 1.08. That would give us 300. And of course, for machining, assembly, and materials handling and inspection, we have already computed for that. We're just going to copy it. So for machining, again, it is 450,000. For assembly, that is 230,000. For materials handling, that is 60,000. And lastly, for inspection, that is 125,000. So let me just fill this up. For JR13, the direct materials is 1 million. For 20x1, its direct labor is 185,185. Its estimated again is still 1 million. And its direct labor that is estimated for 20x2 is 200,000. For RM13, the budgeted for direct materials is 1,750,000. Budgeted for direct labor, that is 92,593. Still the same. Multiply by 1.08. Okay. Okay, now let us try to answer problem number 4. Prepare a budgeted statement showing gross margin for Whitestone Company for 20x2 using activity-based costing. The statement should show each product and a total for the company. Be sure to include detailed calculation for the cost of goods manufactured. Round each amount in the statement to the nearest dollar. So the sales in units for 20x2 for JR14 is 510, and for RM13 that is 4,900. So for sales revenue, again, let's go back to the problem. It is said that Whitestone is planning to increase the prices of JR14 to $355 and RM13 to $455. So the sales revenue for JR14 is 1,810,500, and for RM13 that is 2,229,500. So going to have a total sales revenue of 4,040,000. Now let's compute for the cost of goods manufactured and sold. For the beginning finished goods inventory, since the company is using FIFO inventory method, so the ending inventory that was budgeted in 20x1 would be our beginning inventory. So the ending finished goods inventory in for JR14 is 240,000, and the ending finished goods for RM13 is 300,000. Total of 540,000. For the direct materials, just going to copy this. 1 million for JR14 and 1,754,000 for RM13. Direct labor for JR14 is, where is it? 200,000, and direct labor for RM13 is 100. So for machining, that is 15,000 multiplied by 10. For RM13, that is 30,000 multiplied by the pull rate 10. For assembly, that is 6,000 multiplied by 20. For RM13, it's 5,500 multiplied by 20. For materials handling, that is 25,000 multiplied by 0.8, just 20. And for RM13, that is 50,000 multiplied by 0.8. That would give us 40,000. And for inspection, it's 5,000 multiplied by 10. And for RM13, that is 7,500 multiplied by 10. So now let's just get the totals. So the cost of goods available for sale for JR14 is 1,780,000, and for RM13 that is 2,675,000, and the total cost of goods available for sale for the whole company is 4,455,000. Now let's compute for the ending finished goods inventory. So for the units produced, of course, that is 5,000 for GR14 and 5,000 for RM13 as well. The total product costs is of course to compute for that, we're just going to deduct the cost of the beginning finished goods inventory to the cost of goods available for sale. So the total product cost for JR14 is 1,540,000, and for RM13 that is 2,375,000. So product cost per unit for JR14 is 308. For RM13, that is 475. And based on the problem, the ending inventory finished goods in units for JR14 and RM13 are both 700. So let's just multiply it. 308 multiplied by 700 and 475 multiplied by 700. So the ending finished goods inventory for JR14 is 215,600, and for RM13 that is 332,500, with a total of 548,100. And our cost of goods sold is 1,564,400 for JR14 and 2,342,500 for RM30, with the total cost of goods sold for the company, which is 3,906,900, and the gross margin for JR14 is 246,100. For RM13, that is negative 113,000, and the total gross margin for the whole company is 133,100. So that's how you compute for problem 5-67. Now let's proceed on to the next problem, which is about traditional versus activity-based costing systems, which is case 5-68. Let me read the problem to you. Morelli Electric Motor Corporation manufactures electric motors for commercial use. The company produces three models designated as standard, deluxe, and heavy duty. The company uses a job order cost accounting system with manufacturing overhead applied on the basis of direct labor hours. The system has been in place with little change for 25 years. Product costs and annual sales data are as follows. So for standard model, the annual sales in units is 20,000. For deluxe, it is 1,000, and for heavy duty model, it is 10,000. For the product costs, raw materials for standard model is 10, deluxe model is 25, for heavy duty, it is 42. Direct labor for standard model is 10. It is 0.5 hour at $20. Deluxe model, it is 20, which is 1 hour at $20. Heavy duty model, it is 20, which is 1 hour at $20. Manufacturing overhead for standard model is 85. Deluxe model is it's 170, and heavy duty model it's 170 as well. And the total product cost for standard model is 105. For deluxe, it is 215, and for heavy duty model, it is $232. The manufacturing overhead budget are as follows. For depreciation machinery, it is $1,480,000. For maintenance machinery, it is 120. Depreciation, taxes, and insurance for factory, that is 300,000. For engineering, it is 350. Purchasing, receiving, and shipping, it is 250. Inspection and repair of defects, it is 375. material handling, that is 400,000, and miscellaneous manufacturing overhead costs, that is 295,000, with a total of 3,570,000. The direct labor budget for standard model, that is 10,000 hours. For deluxe model, that is 1,000 hours. For heavy duty model, that is 10,000 hours, with a total direct labor budget of 21,000 hours. And the predetermined rate is 170 per hour. That is computed by dividing 3 sorry 3,570,000 by 21,000 hours. So for the past 10 years, the company's pricing formula has been to set each product's target price at 110% of its full product cost. Recently, however, the standard model motor has come under increasing price pressure from offshore competitors. The result was that the price on the standard model has been lowered to $110. The company president recently asked the controller, "Why can't we compete with these other companies? They are selling motors just like our standard model for $106. That's only a buck more than our production cost. Are we really that inefficient? What gives?" The controller responded by saying, "I think that is due to an outdated product costing system. As you may remember, I raised a red flag about our system when I came on board last year. But the decision was to keep our current system in place. In my judgment, our product costing system is distorting our product costs. Let me run a few numbers to demonstrate what I mean." Getting the president's go-ahead, the controller compiled the basic data needed to implement an activity-based costing system. These data are displayed in the following table. The percentages are the proportion of each cost driver consumed by each product line. So there. So we have new 4 activity cost pool. The first one is depreciation machinery, maintenance machinery. Second cost pool is engineering, inspection and repair of defects. The third activity cost pool is purchasing, receiving and shipping, material handling, and the fourth cost pool is depreciation, taxes, and insurance for factory, miscellaneous manufacturing overhead. And please just refer to this data for your perusal. So we are required to solve the following questions. For number 1, compute the target prices for the 3 models based on the traditional volume-based product costing system. Compute new product costs for 3 products based on the new data collected by the controller, round to the nearest cent. Calculate a new target price for the 3 products based on the activity-based costing system. Compare the new target price with the current actual selling price for the standard model electric motor. And then number 4, write a memo to the company president explaining what has been happening as a result of the firm's traditional volume-based product costing system. And number 5, what strategic options does Morelli Electric Motor Corporation have, and what do you recommend and why? So now let's try to solve that in Excel. So again, I have already placed all of the needed data here, so I'm just going to show you how to solve for the numbers. So for number 1, compute the target prices for 3 models based on the traditional volume-based product costing system. So, oops, I should have merged this to traditional and volume based. Okay, So for standard model, that is 105. For deluxe model, that is 215. Oops. And for heavy duty, that is 232. So our target based on the problem, again, let me go back to the problem. The company here, the company pricing formula has been set to each product's target price at 110% of its full product cost. So 110% for all of the three products. So our target prices are as follows. Just going to multiply the product cost by 110%. So our target price for standard model is 115.50. For deluxe, that is 236.50. For heavy duty model, that is 255.20. So now let's go on to the second requirement. So compute the new product costs for three products based on the new data collected by the controller. Round to the nearest cent. Okay, so since we have new several activity cost pools, so let me list those first. For the first one, that is the depreciation. Let me just copy this one there. So the total costs amount of these cost pool are as follows. For depreciation machinery, maintenance machinery, that is 1,480 plus 120, and that would give us the cost pool of 1,600,000. And for the second one, which is engineering, inspection, and repair of defects, that is 350 plus 375, and that would give us 725,000. And for the third activity cost pool, that is purchasing, receiving, and shipping, material handling. So the numbers are 250,000 plus materials handling of 400,000, and that would give us 650. And for the last activity cost pool, depreciation, taxes, and insurance per factor, and then miscellaneous handling. So that is 300 plus miscellaneous overhead of 295. That would give us 595. So let's see if it totals 3,570,000. Just to be sure. Okay. So we have accounted for all of the manufacturing overhead budget. So now let's compute for the new product costs of the three products based on the new data collected. So for the raw materials, for deluxe, that is 10. I mean for standard, that is 10. Its direct labor is 10 as well. And for the manufacturing overhead, so for the first one, 1,600,000, oops, multiplied by, wait, let me put a parenthesis. 1,600,000 multiplied by 40,000, 40% divided by how many units? 20 for standard model, and that would give us 32. So for the second one, our second activity pool, so we're going to compute that as 725,000 multiplied by 47% divided by, again, the annual sales in units. That would give us 17.04. And for purchasing, receiving, and shipping, material handling, again, 650,000 multiplied by 47% divided by 20,000, and that would give us 15.28. And for the last activity pool, that is 595,000 multiplied by 42% for standard, and then divide it all by 20,000, and that would give us 12.50. And the total product cost of standard model is, well, based on the activity based costing, is 96.81. Now let's proceed on to the deluxe model. So raw materials is 25, its direct labor is 20, and then for the first activity pool, that is 1,600,000 multiplied by 13 divided by 1,000, and that would give us 208. And then for the second activity pool, that is 725 multiplied by 6% divided by 1,000 units sold, that would give us 43.50. And then for the third activity pool, that is 650,000 multiplied by 8% divided by, again, by 1,000, that would give us 52. And then lastly, 595,000 multiplied by 15% divided by 1,000 units, and that would give us 89.25. And the total product costs for deluxe model is 437.75. Now let's proceed on to the last model, which is heavy duty. So the raw materials for this one is 42 per unit. Direct labor is 20. Now let's solve for the first activity pool, that is 1,600,000 multiplied by 47 divided by 10,000 units. That would give us 75.20. For the second one, that is 725,000 multiplied by 47,000 divided by 10,000, that would give us 34.08. For the third cost pool, that is 650,000 multiplied by 45 divided by 10,000. And then lastly, for the fourth activity pool, that is 595 multiplied by 43 divided by 10,000. And the total product costs for heavy duty is 226.11. Okay, now let's proceed on to the third requirement, which is calculate a new target price for the three products based on the activity costing system. Compare the new target price with the current actual selling price for the standard model electric motor. So for standard, again, our new product cost is 96.81. For deluxe, that is 437.75, and for heavy duty, that is 226.11. So again, our percentage for computing our target price is 110%. Now let's just multiply the product cost by the percent of target. So, the new target price for the standard model is 106.49. The new target price for deluxe is 481.53, and for heavy duty that is 248.72. Now let's compare the actual selling price of the standard, which is 110, and the new target price, which is 106.49, and then we're going to get a difference of 3.51. As you can see, the standard model is selling at 110, which is higher compared to the new target price under the activity-based costing. There you go. So, on to the fourth requirement, which is write a memo to the company president explaining what has been happening as a result of the firm's traditional volume-based product costing system. So here I just place a date to, of course, to the president of the Morelli. Oh my god, no. I forgot the R. Okay. Morelli Electric Motor Corporation, and from, of course, yours truly. And the subject is about the product costing results. So, the memo reads, after a thorough review of our conventional volume-based product costing system, the standard model is not actually profitable. Our competitors sell the same product with ours, specifically the standard model, for $106, which suggests that their product costs is below ours, which is 105. If activity-based costing system is implemented, it would result to a more accurate product costing of our motors. It is shown that the standard model's cost is only 96.82 and its target price is 106.50, which is consistent with the price that our competitors are selling. Furthermore, the new product costs and target prices of deluxe and heavy-duty models are 435 per 75, 481.53, and 226.11, 248.72 respectively. Okay, so for the fifth question, what strategic options does Morelli Electric Motor Corporation have? What do you recommend and why? So the first one, of course, ABC should be implemented and maintained. Why? Because it produces an accurate product costing for all of the products for the Morelli Electric Motor Corporation. The second one is target price should be lowered to 6% in order to match with that of their competitors and to regain a competitive position in the market. The third one is the price of the deluxe model must be around its target price, which is 481.53 as computed under ABC. If it is not sold, the company should consider discontinuing the said product. And then lastly, slight reduction in the price of heavy duty model could be done. Yeah. So that's it for 5-68.